Throughout history, civilizations have varied in their capacity for scientific discovery. This process involves investigating nature through empirical observation, logical reasoning, and evidence-based testing to understand the mechanics of the world around us. Science is more than just technology or archives. It is a systematic method of understanding the natural world, relying on demonstrable evidence, testable hypotheses, and rigorous analysis, instead of tradition or supernatural explanations. Core scientific traits include empiricism, where we measure and observe nature directly. Hypotheses must be testable and potentially falsified, meaning we are willing to prove our own ideas wrong with better evidence. For knowledge to be scientific, it must be replicable. Others must be able to repeat an experiment and verify the results. This transparency ensures that science remains a collective, self-correcting enterprise for all humanity. Science proceeds in cycles, observing phenomena, asking questions, testing predictions, and sharing results. This continuous loop allows for the refinement of theories and the steady progress of human understanding over generations. Scientific civilizations require specific conditions, starting with literacy and accurate record-keeping. Crucially, they must believe nature is orderly and governed by consistent principles that human reason can actually uncover and explain. A culture of critical debate is essential. Societies that value proof and tolerate dissent allow new ideas to challenge established dogmas, fostering an environment where the best explanations can eventually rise to the top. Ancient Mesopotamia and Egypt made massive strides in math and astronomy. However, their knowledge remained tied to religion. Astronomy served astrology, and math was a tool for administration, rather than seeking general natural laws. India contributed brilliant concepts like zero and place value numerals. While they possessed sophisticated medical and astronomical traditions, powerful metaphysical currents often prioritized spiritual inquiry over the pursuit of testable external natural laws. Ancient Greece marked a turning point by seeking natural causes for physical phenomena. They developed logic, geometry, and the idea of a law-governed nature, establishing the intellectual foundations for the scientific method. The Hellenistic world built centers like Alexandria to institutionalize learning. In contrast, Rome excelled in engineering and administration, but prioritized practical utility over the abstract quest for new scientific theories and natural explanations. From the 8th century, Islamic scholars translated and expanded classical knowledge. They pioneered experimental methods in optics, chemistry, and medicine, creating a vibrant scientific culture that flourished for several centuries across vast territories. After a period of dormancy, medieval Europe began reviving classical knowledge through universities. The invention of the printing press later allowed for the rapid, widespread sharing of ideas across the entire continent, sparking revolution. In the 16th and 17th centuries, Europe fused mathematics with systematic experimentation. New institutions like academies and journals turned the scientific method into a durable engine for social and technological progress. The Maya and Aztecs achieved incredible precision in astronomy and engineering. Yet, because their knowledge was deeply embedded in ritual and state religion, it did not evolve into a generalized tradition of natural law. A common misconception is that advanced technology equals science. However, engineering can advance through trial and error without theoretical underpinnings. Science specifically seeks the underlying laws that explain how things work. Science is not just a collection of facts, it is a dynamic process. It requires the constant testing of ideas and the willingness to correct errors when new evidence demands a change in thinking. While history shows science emerging in specific contexts, the capacity for it is universal. Once institutions and methods are adopted, any society can contribute to the global frontier of human knowledge and innovation. To be truly scientific, a civilization must treat nature as knowable, reward skepticism over authority, and protect inquiry from dogma. It must fund institutions like labs and schools to sustain continuous progress. Curiosity is universal, but sustained discovery is rare. By preserving an ethos of transparency and self-correction, We ensure that the engine of science continues to transform our understanding of the universe and our place. Historical case studies show that technical sophistication alone does not make a civilization scientific. Without the drive for universal natural laws and critical inquiry, even the most advanced techniques can remain stagnant. China was a powerhouse of invention, creating the compass and gunpowder. Yet, holistic philosophies and an emphasis on tradition often limited the development of the reductionist experimental culture seen in later scientific revolutions. Science also demands an economic surplus. For a civilization to flourish scientifically, it must support specialized scholars and artisans who have the time to investigate the world without the immediate pressure of survival. The globalized nature of science today means that breakthroughs in one country are instantly shared worldwide. This collective intelligence is the greatest strength of modern civilization, allowing for unprecedented rapid advancements in medicine. Ultimately, what makes a civilization scientific is its willingness to embrace change. When we value the search for truth over the comfort of tradition, we unlock the potential for infinite discovery and growth.